Hi everyone. Last topic for the course is going to be something called binomial theorem. So let's get into it. Let's look at a motivation of where this theorem comes into play and what it is used for. So the basic idea is to do certain kind of evaluations and ask questions about the patterns that occur and basically be like, is there an easier way to get to the same result? So here's what we're going to look at. We're going to look at what happens when you have a sum of two things raised to some power. So if you have x plus y raised to power 1, then that is simply x plus y. If you have x plus y raised to power 2, then that becomes x plus y times x plus y, right? Which when you FOIL becomes x squared plus xy plus yx plus y squared, and this is just 2xy. And this is a familiar result because we did this in factoring as, in the reverse direction. You have this identity for x plus minus squared. Similarly, if you have x plus y whole cubed, then I can write this as x plus y squared times x plus y. Now x plus y squared is actually x squared plus 2xy plus y squared times x plus y. Again, we can FOIL. Now here, being careful, you have 3 terms and 2 terms that you're FOILing, so you're going to end up with 6 things. So for x squared, there's going to be 2 of these. So you have x squared times x is x cubed, and then an x squared y. Then you have 2xy times x and y, so 2x squared y and 2xy squared. And then lastly, you have y squared with both of these. So you have y squared x and y cubed. What does that become? Let's see. There is a unique x squared. Looks like I'm going to need more space. Let me move that down. So there's an x cubed. There's an x squared y, and a 2x squared y gives me 3x squared y. And a 2xy squared and an xy squared gives me another 3xy squared plus y cubed. So that's what I had for squaring. This is what I have for cubing. Now let's look at power 4. For power 4, let's say I split it as 2 and 2, right? If I split it as 2 and 2, I have x squared plus 2xy plus y squared, x squared plus 2x plus y. Sorry, 2xy plus y squared. Once again, I go FOIL. It's going to give me 3, 6, 9 terms. So x squared times x squared is x to the 4 plus 2x cubed y plus x squared y squared plus 2x cubed y plus 4x squared y squared plus 2xy cubed plus y squared x squared plus 2xy cubed plus y to the 4. Now let's see what we can combine. We have an x to the 4. Any more of these? Let's see. X cubed y, another x cubed y here, and that's it. So we have 4 of these x cubed y's. X squared y squared, there's 1, 2. So there's 2 of these. Then, there's a 4 here, so that's 6 of those. So 2 plus 4 gives me 6 of these. I'm left with these. There's 4xy cubed and then a y to the 4. Now these are all tedious calculations, and you can only imagine that they get worse when we increase the power to 5, 6, 7, or say 100, which means that and these they come up in many situations, and they have applications, even in probability and tossing of coins, etc. So these are kind of important objects to study. So we by this time we realize that, well, this is not a good process because this is going to take forever if we have higher powers. So what we are going to try and do is see if we can find patterns here. So firstly, let me look at these and see what the patterns are. So one pattern I notice is there's an x and a y, there's an x squared and a y squared, an x cubed and a y cubed, x to the 4 and a y to the 4. So these powers, they sort of work with the same power that is given, right? So if you have x plus y whole cubed, it's an x cubed y cubed. What else? We also notice that the power of x is reducing from 2 to 1 to 0, from 3 to 2 to 1 to none, from 4 to 3, 3 to 2, 2 to 1, 1 to nothing. And similarly, the power of y is increasing from 0 to 1, 1 to 2, 0 to 1, 1 to 2, 2 to 3. Yeah, 0 to 1, 1 to 2, 2 to 3, 3 to 4. So a few things that we sort of establish is powers of x reduce, powers of y increase, but these numbers, we don't have a handle upon them, right? It almost looks like, well, this 2 is from this 2 and this 3 is from this 3, but that hypothesis fails in the power 4 because we have a 4, 4, but then we have this 6. So where's that 6 coming from? So that's going to be the next goal, is understanding where that 6 where these numbers come in from. Now, to understand where these numbers come in from, we introduce some new notations. So I'm going to end this video here, and then we deal with the notation and some other stuff in the next video so that the ideas are separated. So that's it for this video. Thank you.